Hello, everyone. Thank you for joining us for another live webinar session hosted by EE Tech and All About Circuits. My name is Dale Wilson, and I'll be your moderator. Today's session is brought to you by CircuitMind and is titled Architecture to Circuit Schematics in 60 Seconds, an Introduction to CircuitMind AI. Let me tell you about today's presenters. Tomide Adesanmi is an electronic systems engineer and the co-founder and CEO of CircuitMind. Before CircuitMind, Tomide was an electronic systems engineer at BAE Systems, developing high-integrity heads-up display systems and helmet-mounted display systems for jet fighter pilots. CircuitMind is a deep technology company on a mission to increase the life's work of electronic teams by 100 times. Joining him is Basilio Gentile, an algorithm engineer with a PhD in electrical engineering from ETH Zurich. He is the co-founder and CTO of CircuitMind. His expertise lies in applied mathematics, computer science, and electrical engineering. Also today, Zach Peterson will be here. He started his career in academia before working in the electronics industry. He founded Northwest Engineering Solutions, a PCB design services firm focusing on high-speed digital design, RF systems, sensor fusion systems, and mil-aero. His client list includes small startups, Fortune 500s, and some of the biggest names in EDA software. During today's presentation, we will post several poll questions to gather insights and feedback from your audience, so keep an eye out for those. Additionally, there will be 2 pop-up offers from CircuitMind appearing on the top of the chat box. Following the presentation, we will have a live fireside chat Q&A session with Tomide and Zach. You can submit your questions at any time during the webinar using the chat box on the right-hand side of your screen. We will finally provide attendees with a downloadable copy of the presentation near the end of today's session. This will be available in the Resources tab. Thank you so much for joining us, and with that, I'll hand it off to Tomide to begin today's presentation. Welcome.
Introducing the first deterministic AI that helps professional engineers go from architecture to schematic in 60 seconds. Develop better circuits with 10 optimized bombs in 10 minutes. Accelerate your time to market with architecture to schematic in 60 seconds. Reduce respins with automated error checks and analysis. Automatically design for availability and supply chain resilience. And reuse verified design blocks across your organization. The CircuitMind platform takes in your requirements as a block diagram and generates a new BOM and schematic in 60 seconds. Here's how it works. Specify your requirements in the platform as a block diagram. Then specify your low-level design intent in granular detail on each block. Finally, specify optimization trade-offs like size, cost, power, and supply chain needs with sliders. Generate multiple options, 10 options, and compare them to find the best circuit that meets your needs. Finally, down-select to the circuit that best suits your needs and explore the schematic design. CircuitMind has selected components, connected them together, added pull-ups, pull-downs, decoupling, and level translators for a functional design. Explore your BOM, export your design to your ECAD tool, and continue your design, modifying it and adding to it before you go to layout. Get better circuits with less risk in minutes. This is the advent of real automation for electronics teams, finally. Hello everyone, welcome to this webinar that aims to introduce you to CircuitMind and show you how we help electronics engineers, leaders, and managers go from architecture to schematics in 60 seconds using deterministic AI. In this webinar, we're going to introduce you to CircuitMind, my journey and how I got to starting CircuitMind with my co-founder Basilio, and what it does. We're then going to demonstrate the CircuitMind platform live. My co-founder Basilio is going to tell you how it works, what does deterministic AI mean, and what's under the hood. And then finally, I'm going to speak with customers and industry experts on how they're using the CircuitMind platform, the value of the platform to them, as well as the future they see for AI in the electronics design and development process. And then finally, Zachariah Peterson will host a Q&A session with me with your questions from the audience. So please feel free to ask any questions that you have on the platform. Great. So who am I? I'm Tamide. I'm the co-founder and CEO of CircuitMind. Before CircuitMind, I was an electronic systems engineer. I used to build helmet-mounted display systems and heads-up display systems for jet fighter pilots at a company called BAE Systems. Now, ever since I was a boy, I wanted to be an inventor. I wanted to create cutting-edge, next-gen gadgets that could unlock value for humanity. I kind of wanted to be Tony Stark. So my work developing AR displays for aerospace with some of the most brilliant engineers on Earth, that was my dream job. But something was missing. In my role, I spent 80% of my time on tedious routine tasks, like combing across dozens of manufacturer websites, past designs, and procurement databases to find the right components for my needs during component research. Poring over extensive datasheets to understand component features, capabilities, and performance during component selection. Mapping pin functionality, compatibility, performing calculations, and applying standard circuit design principles to capture my schematic. Scrutinizing component availability and alternatives across various distributor websites. And the crazy one, developing test plans, FMEAs, stressing the rating analysis, requirements documents, and power analysis documents. And that wasn't the worst part. The worst part was anxiety. Anxiety that I'd overlooked the crucial detail buried in a datasheet that could lead to an unplanned respin. Anxiety over selected components becoming unavailable and forcing a respin. Anxiety that my component and design choices could be called out during a design review for not being cost-effective or power efficient or size optimized enough to meet our goals. Anxiety. Then I met Basilio, my co-founder, just as he finished his PhD in algorithm design from ETH Zurich. With his algorithm background and my electronics experience, we had a vision to develop algorithms that can act as a true partner to electronics teams, to remove the anxiety, eliminate the tedium, while unleashing electronics engineers on the most creative, most stimulating problems where their expertise is crucial. That was 5 years ago. A year ago, we released the CircuitMind platform to our first customer. And today, we serve dozens of customers who use the platform on real-world projects across EMS, design services, industrial, consumer, automotive, and the medical industries. So, what is the CircuitMind platform? The CircuitMind platform enables engineers to go from architecture to cost-effective, power-efficient, small form factor schematic and BOM options in 60 seconds. With the platform, the engineer inputs their requirements as a block diagram. Today, you might use Visio or PowerPoint to capture your block diagram. Instead, you can capture your block diagram with the dedicated drag and drop interface tailored to electronics architectures in the CircuitMind platform. You can specify your lower level requirements in a more granular details on each blocks. For instance, you should be able to specify the resolution of an accelerometer, the luminous intensity of an LED, the manufacturer of a motor driver, or even the specific part number of a microcontroller. You then specify trade-offs like cost, size, power, availability as sliders. And when you're done, all you have to do is click a button. The CircuitMind platform looks through trillions of component combinations and automatically selects components and generates a schematic and BOM in 60 to 600 seconds. That's 1 minute to 10 minutes. And the best part, you're in full control. The platform is not about providing you with one answer. In the platform, you should be able to go back modify your input requirements, and regenerate different design options to meet your needs. Compare those design options against each other and find the best one that meets the specific goals of your project. And when you're done, you can export your design from the platform into your ECAD tool, whether that's Altium, OrCAD, PADS, DipTrace, etc. And so, for the engineering teams that use the CircuitMind platform, all of this means a transition from non-thorough component research to rigorous component research focused on diverse, preferred, and ideal components. It means a shift from 1 to 6 weeks per iteration for component selection and schematic capture to between 1 to 10 minutes for the parts of your design we can do for you. From going from single unoptimized design options to multiple different design options optimized for power, cost, size, performance, and other criteria. Going from 2 respins per project plus some unplanned respins to fewer unplanned respins because of automated checks designed for supply chain. And then going from manual, tedious documentation to automated templates. That's the transformation with the CircuitMind platform for professional electronic engineering teams. Okay, so let me take you through an example of how one of our customers used the CircuitMind platform to speed up their design process, increase productivity, reduce respins, as well as optimize their designs. An EMS company was in search of one of our customers was in search of a solution to iterate on proposals quicker, speed up their detailed design process, and also left shift supply chain risk avoidance. And so they came and started working with CircuitMind. One of their designs was an industrial sensing and driving system. It had 2 microcontrollers, one of them focused on sensor fusion, one of them focused on communication. And they had a bunch of different sensors, some driving, some display systems, as well as a standard power tree. They wanted to limit the bill of material size and reduce the size of the design. So this is where they started. Let me show you how this design works in the CircuitMind platform. So I already started capturing the customer's requirements in the CircuitMind platform as a block diagram. I'm going to complete the block diagram with you today and generate the design. So the customer wanted an accelerometer, so I go to the build tab, drag and drop an accelerometer functional block and into the interface, into the canvas. They also wanted a gas sensor, so I'm going to search for gas sensor, drag and drop this into the platform. Finally, they wanted a flash memory. Search for that, drag and drop, and I'm ready to go. So next, you can connect each of these blocks together by simply dragging a line from one functional block to the other. In this case, you can see you don't have to specify how these components connect, like I2C or SPI. The platform automatically knows how to connect specific components to others, and so it will do that for you. Next, we need to specify the lower level requirements on each of these blocks, the granular detail of the performance criteria or the parameters that we want each of these functional blocks to achieve. So for instance, in this case, the customer wanted the flash memory to have a memory size greater than 32 megabits. So if you look at the flash memory, you see dozens and dozens of parameters that you can use to specify this requirement. So in this case, I'm going to search for memory size. I want the memory size to be greater than or equal to 32 megabits. They also wanted the accelerometer to be XYZ axis. So I'm going to look for axis, specify XYZ axis. They also wanted the LED to be RGB LED. So I'm going to specify the emitting color of the LED in here. You can even go as far as specifying the part number of a specific part that you want. So for instance, in the microcontroller, the customer knew that they wanted an STM microcontroller. And we can then go to part number and specify and choose one of the part numbers for the STM32. So with that, I've specified the part number of the microcontroller. Now you can also iterate on the architecture of your design. So for instance, in this particular design, this customer wanted the second microcontroller that was used for communication. They wanted to explore different architectures for that. So they had Bluetooth and Wi-Fi communication. So they wanted to explore an architecture where one system or module could do both the controller function, the Wi-Fi function, and the Bluetooth function. In that case, all you need to do is drag and drop the functional block for the Bluetooth and the Wi-Fi into the microcontroller block. Now you're specifying that the microcontroller, Bluetooth, and Wi-Fi should be fulfilled by one system or module. And finally, you can specify the lower level interfaces that you want on each of these blocks. So for instance, you can specify in your accelerometer that you want it to be an SPI slave or I2C slave, but the key is you don't have to. These act more as constraints than requirements. So if you specify SPI slave, you will only choose an accelerometer that can communicate as an SPI slave. So we're going to just leave that open for now. Then finally, you can specify trade-offs like cost, power, size. In this case, we're going to move the size slider to 100%, which means we want to optimize for the lowest possible size we can get. I'm also going to specify that we want only components that are in stock from the various distributors. We collect live pricing and availability data from over 300 distributors worldwide. And so you can specify that you want stock, that components that are in stock either today or sometime in the future. We're just going to leave it at today. Okay, you can also specify your build quantity, which will decide what quantity should you look for components available in. And so once we're done, we're going to click Generate Schematic, and the platform is going to go and generate a schematic. At the same time, as this is running, we can always go back to our input and change some requirements and rerun the design. So for instance, in this case, we can say, well, I want a power optimized design. Specify that I want a power optimized design. I'm going to click Generate Schematic again, and this is going to run the design again in parallel. And I can change the name of that design to power optimized. And so those two designs can run in parallel, and I can keep going back to the inputs, changing things and regenerating. Maybe I want a cost optimized design, regenerate, and just keep regenerating many different design options and comparing those options against each other. So that's up to you. So these two designs are going to be running in parallel. I'm going to visit one of the designs when it finishes and show you the details. But for now, for this demonstration, I'm going to show you 3 different designs that I generated with the same inputs, with the same requirements as what I just showed you, but with just a balanced design, which is 33%, 33, balanced across cost, size, and power. With the cost optimized design, that's 100% cost, and a power optimized design, which is 100% power. So let's compare 3 designs that have been run. This took 2 minutes, 7 minutes, just over about 13 minutes here. So we're going to compare these 3 design options against each other. So we're going to go to the Compare tab and look at these design options. As we can see, the cost optimized design, which is the second design here, had a cost of $13, while the power optimized design had a power of had the price cost of $27, which is almost double of the cost optimized design. However, the power optimized design is consuming 14 milliwatts, which is 95% less than the power that's being consumed by the cost optimized design. So this is how you can trade off different design options, iterate on them until you get to the design option that best suits your needs. Okay, so now let's deep dive into one of these design options. Assuming you've generated, let's say, 10 different designs, you've iterated, mixed and matched, and found a design option that you really like in terms of size, cost, power. You can then go into the details of that design option and explore the output. So let's go to the cost optimized design. I'm going to switch when one of our designs finishes here, but let's start exploring the outputs. So in the outputs, you get a summary of the design requirements that you put in. You can export this and the architecture into a functional requirement document. In the next slide, you get your hardware design tab. So in this hardware design or your schematic design, the platform has selected components for you, connected them together, added pull-ups, pull-downs, decoupling capacitors, level translators, crystals, and even suggested regulators. It's done everything you need to get to a functional design. And this is how it knows what the bill of material cost is and the power consumption is and what the size could be, because it's chosen all of those components that are needed for this design to function properly. And by the way, the design that we generated during this webinar has completed, the size and stock optimized version. It took us about 3 minutes. So that's how quick you can get a design out of the platform. So I'm going to switch to this size and stock design and just show you, you get your summary, you get your hardware design. And by the way, the power optimized design has also finished. So you get your hardware design where it's selected components, connected them, added pull-ups, pull-downs, decoupling, level translators. Again, everything to get you to a functional design. This is where your engineer can then take this functional design, add more to it, modify it with their own experience to get to that last mile, get through that last mile of the design. So you also get a bill of materials. So that bill of materials has your standard BOM with, part name, descriptions, designators, quantities, and price. This BOM can be exported. You get your procurement information. So this is a more detailed BOM that gives you information about what distributors to purchase these components from, what the quantities you can purchase them in are going to be, the price breaks, minimum order quantities, and the quantities available. And if you specify that you want parts in stock, it will make sure it finds components that are in stock from the distributors in the right amount. So this is your full procurement information. You get power analysis as well as other types of analysis that you can get out of your design. You get validation checks. You get detailed verification checks like interface pull-up checks, voltage and margin checks, I2C address checks, capacitor voltage derating checks, nets checks, many more checks. This is one of my favorite parts of the platform. The fact that you can reduce the amount of manual errors that people usually make in a design by having an engine. And by the way, this is a separate engine from the engine that generates the design. It's a separate engine that does DRC checks on your design. And this has so much more data than you would see in any other design engine. So it goes through all of these checks for you. And then you get engineering notes. And the engineering notes are the assumptions made by the platform. The assumptions like configurations, addresses of components, and these are all put together for you to enable your engineer to take this design and move forward with it. Because your engineer is going to need to have information about how the platform did the design and the assumptions it made. And then finally, you can export this design into your design tool, whether that's Altium, OrCAD, PADS, DipTrace. We support so many different formats. And what we do is we export a full project file as well as your symbols. And we can plug into your own symbol and footprint libraries. There's more we can do. We can also plug into your preferred manufacturers. We can plug into your preferred pricing. And there are many integrations that we support. So I'm going to show you how to export into your ECAD tool. Click on this button, Export, and choose your ECAD tool from the drop-down over here and click on Export. It's just going to take a few seconds as it loads my files, zips them up, and exports them onto my computer. Perfect. That's done. Have it in my computer, uncompress it, and I'm ready to go. So I'm just going to copy this folder, move it into my workspace, and copy that over. I'll open up Altium, open a new project, navigate to my file, my desktop. Just open that up. And yeah, now we can see my schematic with all my libraries ready for me to go. Just zoom in a bit here. Just move around a little bit. And my schematic is ready in Altium for me to complete and modify and take into layout. That's how you go from architecture to schematic in 60 seconds. Okay, that was how this customer developed their industrial sensing and driving system in the CircuitMind platform, optimized their design, got different options, and chose the design that they wanted to go forward with. At this point, I'm going to pass it over to Basilio, my co-founder. He's going to tell us about how the CircuitMind platform works. What's under the hood? How can we automatically generate these optimized circuits and schematics very quickly and accurately for your needs? Thank you.
Hi, everyone. I'm Basilio, co-founder and CTO of CircuitMind, and I'm going to answer this question: how does ACE generate a schematic? So in other words, how do we go from the left, from a block diagram, an architecture, to the right, which is a full circuit schematic? What's there in the middle? So to answer that, let's consider a very simple example with a microphone, a microcontroller, and a cellular transceiver. The first step is for us to query our database of electronic component digital twins. Now, this query will include the low-level requirements that you specified on the microphone, microcontroller, cellular transceiver, like Tomide showed you before. And the query is going to return all the components that satisfy those requirements. So the next step is to actually choose those components. And to show you how we do that, I'm going to limit myself to a very simple example where there's only 3 options per block. Obviously, our library is much bigger, but this is just for the sake of illustration. Now, because there are 3 options per block, we want to consider all the possibilities here. And so we want to consider to use a light blue microphone, a white microcontroller, and a green transceiver. And we need to check that these 3 components are compatible with each other, accounting for protocols, voltage levels, noise margins, and so on. And then after we establish that this is the case, we want to consider, instead of the green transceiver, the red one. And maybe in this case, we find out that both the red transceiver and the light blue microphone need UART, and the white microcontroller only has 1 UART port. So this is actually an impossible combination. And we go on and actually try that with all the possible combinations. Obviously, some of them will be incompatible for a number of different reasons, and we'll be left with the ones that work together. And so in the next step, we map those to the space of engineering criteria. They can be cost, reliability, power, and size, for instance. And each of these combination of components will map somewhere in this space. Some of them will be better for cost, some for power, some for size, and so on. And ultimately, the engineer will be presented with a number of different options and will be able to choose the design that fits them best. And it's important that this is not just a combination of components, but it's an actual design. So I'm just expanding on 2 of them where we have designed the whole schematic, including the auxiliary components. We've added automatically the regulators, the level shifters, the circuit protection, and so on. like this is a little bit more in detail, the fact that after picking the components, we have set up each of them. So for instance, in the middle here, you can see that the two different, the same component has been set up differently depending on how the address pin is configured. And we've also added non-functional circuitry like circuit protection on the right. And you can imagine that what I showed you was just 3 options for each block, but on a more realistic design, we're going to have a number of options for each block. And from the 27 combinations that we saw before, real quickly, we explode to a very, very high number, which is equal to the number of grains of sand on planet Earth times 100. So this is how many different circuits the A schematic generator explores to present you and assist you with the best ones that it has found. How does it actually do that? Well, we don't go through all these combinations one by one. Obviously, we do it in a smarter way. And what's important is that the algorithm behind this is one of deterministic AI. So it's an algorithm that is reproducible. So same input is going to give the same output. Obviously, modulo procurement, real-time procurement changes. It's transparent. So we know exactly what it does. We understand it, and it's based on hard engineering rules that come from decades of experience. And finally, it's verifiable. So the circuit is fully annotated with currents, voltages, the ancillary components, and so on. So we have all the information to understand it and to run a number of verification checks, which is the ones that Tomita showed before. So these are the 3 properties of our deterministic AI. It's reproducible, transparent, and verifiable. One word about the database of electronic component digital twins that I've mentioned at the beginning. The way we construct that at CircuitMind is by using a wide range of sources, from datasheets to application notes, and through a very rigorous modeling process that alternates programmatic extraction of information from these datasheets, human verification and completion, to programmatic checks, coupled with redundancy and auditing. This ensures that we have a very accurate set of components and that the information in there is traceable, resulting in a complete library. So in a nutshell, to put it all together, the way we go from architecture to schematic is via this trusted library of digital twins that is used by powerful deterministic AI algorithms. Thank you so much. And now I'm gonna pass it on to the testimonials of our customers.
My name is Gil. I'm 42. I've been an electrical and engineer and a mechanical engineer for about 20 years.
My name is Donovan Wallace. I'm the VP of Electronics at Design First here in Ottawa, Canada. I've been in the electronics industry for over 35 years.
Hi, I'm Steve Auger, and I work for Design First.
So, my name is Drew Reedy. Bit of background about me. I was a design engineer at BAE Systems for 12 years. I'm now currently a field applications engineer at a global distributor of electronic components.
Sarmat Kamara, background always has been electronic for the last 27, 28 years. Spent most of my time with the EDA company. Was with Mentor Graphic for 23 years, in charge of the application engineering team for the electronic system design.
So Vervix is an engineering company that focus on building the best designs with the minimal export of, spin-off, not exports. Based on all the experience and in the military and the startups that I've been, because they all had the same theme, which was do the most with the little that you've got and be creative.
custom design work from soup to nuts, sometimes from the napkin stage or even just waving hands from a notional idea and taking those ideas into functional prototypes, into final volume manufacturing and supporting it through the product life cycle if customers so desire.
I am a design engineer. I work on electronics there, and I've had many years of experience working in various fields such as the military and medical products and commercial.
I'm part of our Altair CTO office, Vice President of Electronics and Simulation product line. I'm in charge of the product strategy and also business development.
I want to amaze my customers with one-day design. They used to being disappointed from their suppliers, the contractors, and I want to give them the best experience and show them how engineering can be fun and fast, and not costly and draggy like it's usually were.
So electronics engineering is a pretty in-depth field needing a lot of expertise, but there are some elements of the activity a design engineer does from day to day that are repetitive in nature that could be automated by using I've always seen sophisticated tools to reduce some of the tedium, searching for components, looking at permutations and combinations of things, doing intelligent searches. It's something that's been there in the back of my mind, and that's what attracted me to circuit mining when I first came across it. I think there's opportunity to add some technology into this area to make the work more effective and more time efficient. And so I was attracted to that notion, and I wanted to explore it some.
So I would like to reduce the overall time to design a product. It's a very competitive market that we're in, and our time is expensive. So ideally we would like to shrink that as much as possible. So with Circuit Mind, we're hoping that we can take advantage of the technology to auto-generate some circuits and make the design process a lot faster.
So we started with Circuit Mind about a year ago. We do designs that have a blank sheet of paper, and we look at different ways to implement, and we want to sort through different, like I said, permutations or combinations of components, which can be quite tedious and time consuming because we're trying to optimize for cost, for size, for power, and for availability, and sorting through all those permutations at times is actually impractical. Sometimes it's actually totally impractical to do that, and you're kind of saying, what can I do in X number of hours, X number of days, and see which the best you can. Does that mean it's the most optimum one? No, but it's the most optimum one I could find within that time. And if there are tools that can sort through that in a sophisticated, intelligent way, we can truly say we have an optimum design for that particular use case.
Well, I hate to read datasheet. And there are so many components doing the same that you're not, it's like a rabbit hole that you go into and you don't know exactly what to choose, because there's tiny differences that doesn't seem really countable. And Circuit Mind allows me to skip the step, that going through the basements of Mauser and DigiKey, and just get, I have a characterization of a design, and I can go straight to work with the schematics, without trouble myself with component selection and doing the manual work of of the schematics?
So there's several facets to CircuitMind that are useful. One is at the sales stage, where we're initially engaging with potential clients, and with CircuitMind, there's a possibility for certain types of products that we can actually, right in the sales meeting, we can start generating block diagrams and giving them some idea as to how feasible the product is and the cost, that sort of thing. Second is to move through the initial stages of development, which is the concept design, and that involves block diagrams and preliminary bill of materials, what the possible cost could be. And CircuitMind is very useful in that respect, because we can quickly do block diagrams and generate possible circuits using it.
I'm kind of a technology geek. I was looking to see what's out there, what's new. When I first came across the idea, I said, here's something that we should look into. We meet weekly with my team of engineers and propose the idea. Immediately I got a kind of like, I don't know. Just like kind of dismissive, probably hyped up, probably just, that was the response I got. And I said, we should look into this. There are definitely opportunities to make our day-to-day work more efficient, more effective with some tools. And so I basically, I went to the company CEO and I proposed this idea. There's some tools we can look at that may offer us some advantages over our competition. And as soon as I said that, his words were like, okay, go ahead and do it. And even define an internal project and charge number for it, so that we can spend some time looking at the tool to see how it would help us.
I guess as the world has embraced the likes of a ChatGPT in the last sort of 12 months or so to help with their day-to-day activities, I think it's time for engineers to actually open up to the idea of using automation to help with the decision-making processes. I guess some more adventurous engineers already are, but not all of them. Using a tool such as ACE, I believe, actually to help optimize the design, especially around parameters such as size, power and cost, can be really beneficial, especially being able to generate multiple instantiations of the design, allowing engineers to make increasingly informed decisions. Being able to use that tool to create more and more ideas, like almost outside of the box, that maybe doesn't have the time to do themselves. Especially, in the sort of format that you guys have sort of created, the GUI that's actually quite user friendly and I believe is accessible to all levels of engineer. Something that some of the other tools that people are using today lack at present.
AI will have a play when it comes to design with optimization, because it can help the electronic design engineers quickly analyze vast amount of data, which is really would be a little bit hard for an engineers to do it kind of with traditional application, traditional tools. So AI will help identify patterns that human beings or design engineers can overlook, for example.
This is the design that I made. It was made with the platform. It's a simple USB hub. It has a 5 volt from the USB in, or a power connector for 12 volt, and then the USB just distributed it. So this is the design that was made on CircuitMind, and I changed the layout so it would be more convenient for me. It's been like let's say 20-30 hours project instead of 40 or 50. So that's a big time saving for me, because I can work on more project, take more meetings instead of doing the manual labor.
Thank you so much, Don, Steve, Gil, Sarmad, Drew. It was great having you. Thanks for sharing your experiences and insights with our audience. I'm going to pass it over to Dale now to take this forward.
Okay, I think we're all here. That was such a great presentation. Thanks, Tomide.
Thank you very much, Zach.
So this is super interesting, and it's great to always see it live. And I think that really helps make all of this much more substantial and tangible. So that was such a great demo.
Thank you very much, Zach. Appreciate it.
Yeah, so we have many questions here. The questions just started coming in like a flood. So to everyone that's out there listening, I apologize if we don't get to your question ahead of time. They will get sent to all of us, and we will do our absolute best. So Tomide, if you're ready, let's just jump right in.
Perfect. Let's go.
Okay. So first one. This question asks about two solutions that the platform might generate. Mm-hmm. So can you set the best compromise between cost and power consumption between two solutions that you've found before?
I'm not sure I understand the question. So can you set the best compromise between cost and power with...
I think the question is, suppose you found one solution, it's cost optimized, another one, it's power optimized. Can you then take that and then balance?
Oh yeah, perfect. Yeah, that's a great question. So the platform is designed to help you iterate between your design options. So you saw those sliders that I showed. Those sliders they're dynamic. So they change with the way you change the sliders. So if you get one design that is fully cost optimized, 100% on the cost, and another design that's 100% on the power, you can always go back and then say, can I get something that's 50-50 cost and power, for instance, and then get something in the middle. So on average, we see our customers generate about 5-6 design options that you can compare against each other. And some of those will be somewhere in between.
Okay, that makes sense. Let's move on to the next question. This question asks, the function blocks you used were already defined. Can I define them by myself?
Not really. The functional blocks are developed to match component categories that exist generally in the web. So if you go into Mouser or DigiKey or even a manufacturer website, you'll see the different component categories that they support, whether that's a microcontroller or a Bluetooth block or a temperature sensor and so on. So we develop those component categories so that they match general and generic functional blocks so that you don't have to specify a functional block. If there's a functional block that we don't support in the platform that you want us to support, as a customer, you can also contribute to that.
So someone could request a specific functional block.
100%. They shouldn't need to. We have an internal taxonomy that should be able to characterize all the different functional blocks that a person is looking for. But yes, of course, you can request a functional block if we don't support it.
Makes sense. Okay. If somebody does not like just one component in a generated design, can they select it and choose to change it?
Exactly. You can do that. So there's some functionality I didn't show you in this in this kind of showcase, and that's because we don't have enough time to do that. So I will be able to show you kind of more functionality. And this specific feature is that in a particular design, you can edit the requirements on every single design that comes out. And there is a feature where you can edit parts of a design. You can lock down certain components to certain functional blocks and say, on this, I only want to leave one functional block open. I want to keep the choices you made for me, leave these others open, and then regenerate your design with only that open block. And so those are the sort of kind of types of functionality that we're trying to use to create this sort of more iterative workflow.
So it basically starts looking through that new branch of permutations.
Exactly.
Okay.
So you can go down one rabbit hole if you want.
Okay.
And we'll be doing more in that direction, but that's kind of like a starting feature.
Okay, that makes sense. Next question. Where does the data that is used to calculate the trade-offs between cost, size, and power, where does that data come from?
So different places. So like my co-founder Basilio talked about, we in the background create what we call electronic component digital twins. And these digital twins contain information from datasheets, for instance. So all the information you normally be reading in datasheets. So connectivity information, voltage, attributes, configuration information, all of that information has been extracted and characterized to form this digital model of a component. So for instance, the information about power consumption will come from there, because we will do that calculation while generating design. The information for size will also come when we're characterizing these components. And then the information for things like cost and availability will come from live pricing and availability data that we pull from over 300 distributors and manufacturers in the platform. So again, I said I didn't show you all the features, but we have a feature in the platform where you can specify what distributors and what manufacturers you want us to collect data from. We connect via APIs to those distributors and manufacturers, and we can pull in live information about this cost and availability.
So that actually is a nice segue into another question, which is actually related to what you just mentioned. How is the system updating with the latest components from suppliers, some of which might not be available on the open market? It sounds like you're already checking and pulling in that data.
Yes, so we already plug into these distributors and manufacturers with APIs from different sources, and then we normalize that data. And you can, again, you can select what ones you want to consider. We automatically select what we call trusted distributors, the ones the Mausers, the DigiKeys, the Avnets, the Arrows, but there's so many distributors that you can go in there and down select for your needs. In fact, we can enable you to create your own distribution. So some companies would say, I have my own stock in my company, and I want to integrate with you to tell you what components I have in stock. We can also do that.
Okay, shifting gears here for just a moment. Power usage is often mostly dependent on firmware design. So what are you assuming in order to get the power usage figures? And I think this is specifically in those cases of processors where firmware is playing a role.
100%. Okay, so that's a great question. And we don't kind of claim to do all your power analysis for you. We're trying to give you an indication. So we won't take into account the firmware details. You're still going to have to go write the firmware and do some further power analysis. The information we're taking into account for this sort of preliminary initial power analysis that gives you an indication is the typical currents, max currents, and then the loads on them. And then we do like a preliminary power analysis. This gives you an indication. Obviously, it's not perfect, as in it doesn't take into account your detailed firmware requirements and information, but that's usually useful for this sort of initial preliminary kind of information, or sorry, outcomes.
So how does the platform handle analog circuit blocks, for example, for signal conditioning circuits?
Yeah, so that's a great question. At the moment, the platform helps with more the digital parts of your circuit, as well as some of the power parts of your circuit. It doesn't yet do analog for you. And so if you walk back to what this platform is trying to do for you, the main thing is that it's helping as a partner to you. It's working as a partner to you, a reliable partner that does some parts of your design, and then you do some parts of your design. And so it's not aiming to do all of your design all at once. It's aiming to help you capture your architecture, do some parts, and then you go away and do some other parts in your ECAD tool. So it really works well with seamlessly with your ECAD tool. When you talk with us, we'll tell you what parts of your design we can capture and what parts we can't capture. Many of the analog things we can't yet capture. There's a roadmap for that. There are things like, ideas that we have around equation-based design generation and simulation-based design generation, but that's going to come later. We're going to start with we've started with this sort of co-design capability that allows you to be doing the more creative parts of your design, that where you can focus your energy, your mind share, and your sort of experience and expertise.
Another question, can someone input an existing design to run design rule checks?
That's probably the most common question I get on a daily basis. You can put some parts of previous designs in your platform, but not to just do design verification checks, and that's because it's very difficult to really understand what you've done outside of the platform and try to figure that out before then doing the verification. But what we do help with is we help with reuse. So what you can do is many companies have lots and lots of design blocks within their company that's verified and that's trusted. And so you can actually import some of those design blocks. You can characterize them, and then you can reuse them in the design generation alongside us generating some of the parts of your schematic from scratch. And we'll do checks on those sort of reusable sub-circuit blocks as well.
Okay. Some other questions relating to privacy. How is the privacy managed and protected?
Pricing managed?
Privacy.
Privacy.
Like data privacy.
Yes. So we have a walled garden between all the organizations on our platform. Privacy is very high. We take privacy very, very seriously. So we have high enterprise grade security on the cloud. And we've gone through many security assessments with some of the largest companies in the world. So we're very happy to talk to your IT teams and your legal teams. But the key here is no other organization can get your designs. Your designs are yours. Your input requirements are yours. All of the information is yours. And, not accessible to anybody else.
I think a related question here that has come up from a few people is about libraries.
Yep.
So who owns and maintains the libraries? Are these CircuitMind's libraries, or could a customer input their own libraries? I think this will come up in the context of like schematic symbol generation. Yes,
it's a great question. So it depends on what you mean by libraries. If you mean digital twins, which is this sort of more contextual data about a component that almost essentially replicates a data sheet, that's ours. We create it, and you can use it for generation. But if you're talking about symbols and footprint libraries, we have our own symbols and footprint libraries. You can integrate your own symbols and footprint libraries, and your symbol and footprint libraries that you integrate will be yours, right? We don't want to use that. They're going to be yours. No other person can use them. You can choose to use your own symbol and footprint libraries, or ours, or both of them combined, depending on what you want. For the digital twin database, we own that.
Okay. So here's one more question related to the latest ICs. And I think this is important because I've actually had to deal with this myself.
Yes.
Some of the latest technology or ICs are behind NDAs.
Yes.
So
yes.
How do we get that data into ACE so that ACE can use that as part of design generation?
Yeah, that's a great question. We do this for most of our major customers. So we have a protocol where we go under NDA with the component supplier. We already have NDAs with a lot of the major ones. And as long as you're under NDA with them, we can show you parts that are under NDA from them as well. And so, because they want to give you access to their component, they really usually want to go under NDA with us so that they use us as a channel to present their parts to you. So that's a sort of a foolproof protocol that we've developed internally, and we kind of support components under NDA.
I think the last question that we should do here, because we are running out of time, relates to the solution generation here. And this is, I think this is going to be interesting. So what happens if a solution cannot be found from the input architecture requirements and constraints? And maybe the corollary to that is, have you ever found a set of inputs that don't generate a solution?
100%. You can specify that you want your design to have an operating temperature range between -180 and positive 250, right? Our goal is to give you as much information as quickly as possible. And so from the input, it's going to start warning you about potential designs that are going to be infeasible. And then on the output, we want to give you as much information for design, is infeasible, given the digital twin database, to give you enough information so that you can change the requirements and get a feasible design. So what we do is live and continuous validation throughout the process.
Okay. So just to clarify, you have not seen?
No, I have seen all the time,
okay.
Because it's people inputting information as well as our, there are cases where there's no potential feasible design with all the characteristics you specify. So that will happen. But the key here is to give enough information so that you don't spend too much time, and you can kind of find the issue in your specification.
Okay, makes sense.
That's what we do. Yeah. So you want this to be something that can communicate with you and tell you, hey, dude, I think you did that wrong, and this is the reason why. Or we are not getting to a solution because of this reason.
Okay, that's great to hear. I believe we're out of time, but as I told everyone that has asked so many questions, this is a huge list of questions here. These will be sent over to us, and we will look at them. And Tamidi, I'm sure you'll take care of those personally if you can.
100%. And just one more thing, I can see a lot of people asking about licensing information. So if you do have a question on that, there's a request a quote button on top of the chat, and you can just kind of request a quote from us. I will get in touch with you.
That's great. Great.
All right. Well, thank you guys. That was a great presentation. And wow, yeah, we could have been here another hour answering questions, I think, very easily. So maybe we can do it again sometime.
Definitely.
And everyone, thank you in the audience for your participation. In just a moment, you'll be redirected to CircuitMind's partner content page on All About Circuits, where you'll be able to view this session on demand and check out other great resources. So thanks again to everyone for your time, and we look forward to seeing you at another live session again sometime soon.